Hello guys, in this video I'm going to show you how to solve Dutch national flag problem, which is a pretty famous interview questions. So let's dive right in. Given an array containing zeros, ones, twos, sort the array in place. Right? You should treat numbers of the array as objects. Hence, we can't count 0, 1, and 2s to recreate the array. The flag of Netherlands consists of three colors: red, white, and blue. And since our input array also consists of three different numbers, that is why it is called Dutch national flag problem. Right? So very interesting. So for this given input, right, as you can see, it consists of only 0, 1, and 2, but in a arbitrary order. So our task is to move all zeros to the head, 1 to the middle, and 2 to the right, right? Two distinct regions, 0, 1, and 2, right? So how to solve this problem? One observations we can make here is that if we somehow uh, if we are able to move all zero to the head and all twos to the right, then it's automatically sorted, right, in the correct order with with 0, 1, and 2, right? So from that observations, we can uh, actually we can use two pointers uh, to set the boundary for one for 0 and 2, right? For 0 regions and 2 regions. Okay, so I will start with 2 pointer, right? Uh, okay, this pointer will signify the boundary for 0 regions, and this one will be the boundary for 2 regions. What what it means is all the number to the left of this pointer will be 0, right? So initially we start at head, right? We will expand this pointer to the right, and as we as we add more zeros to the left, right? Same here. This pointer to the right will be all twos, right? So sorry, it should be from this input instead of the output. So at the end, what would be the positions of two pointers at the end? So it would be both pointer will point to this one, so that the left of this pointer correct will be all 0. Same here. The right of this pointer will be all 2. Right? So here is a 2 pointers problem. So we need in order to move all zeros to the head and all twos to the end, we probably need another pointer, which is a working pointer, right? So we will consider every number from start to finish, from left to right, right? So as we look at each number, there will be three possibilities, right? Either 0, 1, or 2. So what if it is 2 in this case? The current number is 2, right? So we probably want to move it to the end, right? It means I want to make a swap here between the current pointer, the number at the working pointer, and the number at the dollar pointer here. So I will make a swap here. 0 come here and 2 come here, right? So after 2 is moved to the right, I probably want to expand uh, the two regions, right? So move the dollar pointer leftward, right? So it means all the number to the right of the dollar pointer will be 2, right? So after the swapping, do we continue uh, to investigate the next number? No, we're not done with the current number yet, right? So after the swapping, right, 2 has been moved to the end, and uh, we must continue to look at the current number, right? It's still a mystery here. So the current number has not been checked yet. So again, we look at the current number, the current pointer is 0, so it should be on the left. Okay. So the probably I want to move it to the um, same logics here. We want to move 0 to the left, right? To the left side, right? So I want to swap it with the correct pointer, right? The number to correct pointer. But it actually is the same here, right? So after the swapping, it stays the same. But we want to uh, same here. After move 2 to the right, we expand the two regions. Same here. So after we're sure that it is 0 here, I will expand the 0 regions, right? Okay. So after that, so after these operations, I will move the current working pointer forward, right? So again, look at the current. We look at the current positions here. We look at the current number, right? Which is 2. So 2 should be to the right. So I will make a swap between 2 here with the boundary of two regions, which happen to be 2 also, right? So it would stay the same after the swapping. So after swapping, I will expand the two regions here, right? Okay, so I will continue to look at the current number, right? Which is 2, again 2. So I will make a swap between 2 and the number of the boundary of two regions. So 2 will come here and 1 will come here. Okay. Okay, we continue to look at 1. If it is 1, do we want to make a swap with anything here? No, right? Because we only care about zeros and 2, right? We move all zeros to the left, all 1 to the right, and the all 2 to the right. All 1s will be automatically adjusted to the middle, right? So for 1, I will just go ahead. I will just skip it, right? Okay, the current number is 0, so it should be to the left, right? So I will make a swap with number of the boundary of 0 regions. So 0 come here, 1 will come here, right? So after swapping, I expand the 0 regions. Sorry. So it should be like this. Okay, we continue to look at the current number, which is 1. So for 1, I just skip it. Right? So probably when the current pointer reaches the boundary here, do we want to stop here? No, because we only show all the number to the right of the dollar pointers E2s, right? We're not sure the current number. We're not sure the number at the boundary. What is it, right? It happened to be 2 here, right? But we need to check it, right? So, because it's 2 at the current pointer, so I will make it a swap with the number at the boundary of the two regions. So after the swap, it will stay the same. But I will expand the two regions by moving the dollar pointer leftward. Okay. So after these operations, the working pointer is greater than the dollar pointer, which is signify the two regions. So I probably want to stop here, right? There's nothing to check to the right because all the number to the right of this pointer is 2, right? So there's nothing to check here. Okay, that's basically how we're gonna solve this problem with 2 pointers. So let's dive in coding. Okay, so we need two pointer, right? Let's say um, let's say left and right. Left start at 0 and right start at the last index, which is array length minus 1. Okay, we need now the pointer, which is the working pointer. uh, Here I'm going to use a while loop. Why is that? Because it will be easier to decide when to move the current pointer uh, forward, right? Because after swapping, we could uh, we could stay we could keep the working pointer the same for the next iterations, right? So probably I want to use a while loop here, and I need a current pointer start at uh, start at 0 as well. So I want to loop as long as the current pointer is still less than or equal to the right. So when it is here, which is current is greater than the right, I will stop, right? So so there will be so at each iterations, when I look at the current number, right, and decide um, when I look at the current number, it will be either 0, 1, or 2. And based on those numbers, based on what it is, we decide whether to move it to the right or to the left, right? There will be three cases here. If the current numbers is 0 or current number is 1, else if it's else will be the current number is 2, right? So if it's is 0, then I want to make a swap between the current pointer and I want to make a swap here. We don't have the logic for swapping yet, but uh, let's call it a swap function that will swap two numbers at two index, right? Indices. So I will pass in the array and the two index that I want to swap, right? So we want to swap the current, right? The current, the number at the current index and the number at the left index because I want to move 0 to the left. So after these operations, I want to expand the 0 regions. It means I will increase left. And if it is 1, if it is 1 here, then I probably want to skip it, right? We don't care about 1. So I keep it just by increment the current pointer by 1. So we will go to the next loop, okay, and check the next number. If the current number is 2, then I want to swap the current with the right, which is the boundary of 2 regions. Right. After that, I will expand the 2 regions by decrementing right by 1. So that is it for this one. The final thing here is to implement swap functions, which is a pretty easy task. Alright, and let's say index 1, index 2. So a little trick, JavaScript trick here to do the logics with just one line. Index 1, index 2. On the right side, I will change the order to index 2, then index 1. Okay. Now, okay, I think that is it for this one. Let's run the test. Yes. 7. No. 2 and 7. Okay, let's see. Whoops. What's wrong here? Let's see the test. Oh, we have one failing test, which is the second case here. Okay, let's. What is wrong here? I think it's better to just run through it manually here. Right. So if it too okay, here the current pointer. Okay, if it 2, it should be on the right. So I do swap it, 2 come here and 0 come here. After I expand its regions, 2 regions. Okay. Okay, we continue to look at the current number, which is 0 here. So it should be 0. Okay, we compare 0. Now, we want to move 0 to the left, right? So I will make a swap with this pointer, right? Which is a boundary for 0 regions. It will stay the same. So after these operations, it will stay the same, and I will expand the 0 regions like this. Then probably here If it is the case that the working pointer and the lab pointer pointing to the same number, right? And after making this swap here, we increment this the lab pointer, right? So we expand the zero regions here. So in that case, there will be no point. If it is current code now, it will keep checking the current number here, right? So that is something we must fix, right? Because there's no point of just keep checking here, because after expanding the zero regions here, all the lab will be zero, right? So we we want to keep checking the next number instead, right? So if we check here, which is if the current is the same as, we can, let's say, if the we can we can compare the lab here. If the lab is greater than, if the lab is greater than what, greater than the current, I want to reassign current here to the lab. So after swapping, we'll expand the iterations and also reassign the current to the lab here. Lab is greater than current. Okay, the current will be the lab. Okay, I think it will work. Okay, it works. So that is it for Dutch National Flag problem. Sorry. Thanks for watching. See you in the next video.